my dear students of class 10. Today we'll be starting with a new chapter, and that is electrolysis. So the term electrolysis, you can see it can be broken down into two different terms. One is electro and the other one is lysis. So from the term itself you can make it out. What does it mean? It means that whenever an electric current is passed through an aqueous solution of a compound, it brings about a chemical reaction. The decomposition reaction takes place. Okay, so what you have to remember, electrolysis is the process where we make use of external current to bring about a chemical reaction. So now here under electrolysis you have to remember different terms like electrolyte. So electrolyte means these are those compounds when in aqueous solution they will conduct current, electricity. So electrolytes are those compounds which in aqueous solution or in molten state they will be conducting electricity. So they conduct electricity. Now all those compounds like the acids, the strong acids, the caustic sodas, they are what? Electrolytes. Now again, electrolytes, based on its capacity to conduct electricity, it can be again divided into two different types. Okay, the first one is the strong electrolyte and the other one is the weak electrolyte. Strong electrolyte and the other one is the weak electrolyte. So strong electrolytes, by the name itself you can make it out, they conduct large amount of current, electricity. Okay, they conduct large amount of current, electricity whenever they are in aqueous solution or in fused state. So for example, you have all the strong acids like hydrochloric acid, sulfuric acid, and nitric acid as well, HNO2. They are strong electrolytes. Example of strong electrolyte. And the caustic alkalis like KOH, NaOH, they are again strong electrolyte because they conduct electricity to larger extent. Now let's move on to the next type of electrolyte, weak electrolyte. Weak electrolytes, by the name itself you can make it out, they conduct less amount of current, electricity through them in aqueous solution or in molten state. So for example, all the organic acids like CH3, COOH, you have acetic acid, this is the formula for acetic acid. You have base like ammonium hydroxide. Now these are the examples of weak electrolyte. So you have to remember, see, electrolysis, current, electricity is used to bring about a decomposition reaction, and this brings about a chemical change in the reaction. Okay, now let's discuss about the other term under electrolysis. This is electrolytes. Now let's discuss about non-electrolytes. Non-electrolytes means they are the compounds which do not conduct electric current. Okay, non-electrolytes. Now these non-electrolytes, they do not conduct electricity or current, electricity. Example, you have all those compounds, organic compounds again, CCl4, carbon tetrachloride. There's even the electron dot structure of carbon tetrachloride we have already done in our class. So this is one example of non-electrolyte. Now this doesn't conduct electricity. Okay. Now let's discuss about electrolysis in more detail. And this is very important. Okay, understanding of electrolysis is very important. How the process of electrolysis is carried out. To understand this, let's take a simple diagram. Here we have say a container. This container, simple diagram, okay? This is the container, and in this container you have say some liquids present, and this liquid here is electrolyte. Just now we have discussed what is electrolyte. They conduct current, electricity. So this container is known as electrolytic cell. This liquid here inside this container is electrolyte. Now here we have say two rods immersed in this liquid, which is electrolyte. Now these two rods are known as what? They are known as electrodes. So both of them are known as electrodes. Okay, so it's very simple. Container, electrolytic cell. The liquid inside the container is electrolyte, and these two rods which are immersed in this liquid, which is electrolyte, is known as what? Electrodes. Okay, now these two electrodes are externally connected to a battery. Simple diagram. This longer one is positive, the shorter one is the negative. Okay, so whenever these two rods is externally connected to a battery or to a cell, then what will happen? This terminal, this rod will gain, since it is connected to the positive terminal, this will gain positive charge, and since this rod is connected to negative terminal, this will have negative charge. Very simple. Okay. Now this electrolyte, say this electrolyte is AB. Okay. Any compound I have taken it as AB. Any compound, it could be any compound, but in general I have taken it this electrolyte to be AB. Okay. So once the current electricity passes, what will happen? Once you connect this battery and this circuit is closed, and what will happen? Current electricity starts flowing through this wire to this rod, and a system or whole system is made. Now, as soon as this electric current is passed, what will happen? This AB, since it is an electrolyte, it will dissociate into respective cation and anion. Okay, so now this AB is dissociating into A positive and B negative. So you know this positively charged ions are known as what? Cations, and negatively charged ions are known as anions. Okay, this is cation and say this is anion. Now, as soon as this electric current is passed, AB gets dissociated into A plus and B negative. That means in the solution now you have A positive, B negative, A positive, B negative, and A positive, B negative. So this entire solution, once electric current is passed, gets separated into ions, and you will be having positively charged ions and negatively charged ions. Here it's very simple to understand that this cation will be going to the cathode. Okay? Cations will be going to the cathode, and anions will be going to the anode. Now you must be wondering what is cathode and anode. Here these rods one of them is cation, the other one is anion. Now how to identify it? It's very simple. Whenever you make this electrolytic cell and electrolysis is shown in this particular cell, you have to remember the one which is connected to the positive terminal is always on the left hand side. So you can name it as A, B in between, and C. That means on the left hand side you always, this is A, this alphabetical order A, B, C. So This is your anode, very simple to remember, and this is cathode. This is your anode. Okay, please remember, on the left hand side, which is connected to the positive terminal of the battery, is your anode, and the one which is connected to the negative terminal of the battery is your cathode. And in simple way, how to remember it? Alphabetical order. Okay. Now, I told you cations are positively charged. They are positively charged, and positively charged ions will be attracted towards the negative electron. That means this is your negative electron. It implies that all the positive ions will be now attracted to the cathode. A positive will be going to the cathode because it is deficient in negative charge. It will be attracted to the negative charge. Similarly, this negatively charged anion, that is B minus, will be going to the anode. Okay? So very simple. Let me tell you once again. Once electric current is passed through the circuit, here inside the electrolytic cell, the electrolytes dissociates into positive and negative ions. Positively charged ions are known as cations, and cations will be going to the cathode, anions will be going to the anode. This is how the reaction takes place in this electrolytic cell. Now you can see it because of this. As soon as you pass electric current, the reaction has started. The dissociation has started, and they are going to the respective electrode. That means the electric current is used to bring about a decomposition reaction, and this is known as what? This is how electric current is known to bring about a chemical reaction in the process of electrolysis. So what happens now? So reaction at anode and reaction at cathode, you have to write it, okay? So reaction at anode, what type of reaction takes place? You have to remember this. At anode is positively charged, B negative is going to the anode. That means B negative will lose, see, it has one excess electron, it will lose one electron and convert into B neutral atom. B neutral atom. And there is loss of what? Electron. And loss of electron is what? Loss of electron is oxidation. So you have to remember, oxidation takes place at anode. Please remember, this is very important. Similarly, reaction at anode is done, or reaction at cathode. At cathode, which ion is going? The positive charged ion, that is A positive. Now A positive will go to the cathode. It is one less in electron, therefore it's positive. So it will gain one electron to become again neutral atom of A. Here you can see this at cathode there is gain of electron. The addition of electron is taken to the cation, and addition of electron is what? It's reduction. So you have to remember, reduction takes place at cathode. Okay, very simple. So this is the general electrolytic process. Okay, this is general electrolytic process. Please do not be confused. Here I have taken AB as the electrolyte. Okay, and with AB I have shown you how it gets dissociated and how the reaction takes place at anode and at cathode. Now, in next classes, you will be seeing instead of AB, you will be having certain compounds. You can say like NaCl. Okay. Now, similar type of reaction takes place. You will be having more lead bromide, Pb, Br2. You just have to replace this A, B with either of these compounds, whatever is given to you. So first, you have to understand how the electrolysis takes place. So if you have any doubt regarding this electrolytic process, you can ask me through WhatsApp number. Okay? And please, kindly, you have to keep revising it. Without understanding this first topic of electrolysis, the further topics that will be coming in next classes will be difficult to understand. So humble request, please go through it properly, and any doubt, please ask me. Thank you.